Welcome to the first learning unit of Flyer, Circular Design Process. In the first lesson, we will be learning about the basics of circular design. Circular design is a transformative approach that aims to create products and systems that are regenerative by design. Unlike the traditional linear model of take, make, dispose, circular design focuses on closing the loop, ensuring that materials and products are reused, remanufactured, and recycled, thus minimizing waste and environmental impact. Here's a detailed look at the core principles. Design for longevity. Furniture is designed to last longer, reducing the need for frequent replacements. This includes using durable materials and creating timeless designs. Modularity and repairability. Furniture is designed in a modular way, allowing for easy repair, upgrading, and disassembly. This makes it easier to replace or repair parts rather than discarding the entire piece. Use of recycled and renewable materials. Prioritizing materials that are recycled or renewable helps reduce the environmental impact. This includes using reclaimed wood, recycled materials, and biodegradable materials. Design for disassembly. Products are designed so that they can be easily taken apart at the end of their life cycle. This facilitates recycling and the reuse of components. Closed-loop systems. Implementing systems where materials are continuously reused within the production cycle. This reduces the need for virgin materials and minimizes waste. Shift from ownership to access. Encouraging models where consumers lease or rent furniture instead of buying it. This ensures that products are returned, refurbished, and reused. Safe and circular materials. Choosing materials that are safe for both the environment and human health and that can be easily recycled or composted. Let's talk about each principle on its own. Design for longevity. This is about creating furniture that lasts longer to reduce the need for frequent replacements. This involves using high-quality, durable materials and construction techniques that ensure the furniture can withstand wear and tear over many years. It also includes designing timeless styles that remain appealing over time, reducing the likelihood of the furniture being discarded due to changing trends. One example is Vestre, a Norwegian company that designs outdoor furniture with a lifespan of 50 years. They use robust materials like steel and sustainably sourced wood, and their products are tested for durability in harsh weather conditions. Modularity and repairability. Designing furniture in a modular way allows for easy repair, upgrading, and disassembly. Modular furniture can be easily taken apart and reassembled, making it simple to replace or repair individual components. This extends the product's life and reduces waste. Companies often provide spare parts and repair guides to support this principle. One example is Herman Miller, who offers modular office furniture systems that can be reconfigured and repaired. Their Aeron chair, for instance, is designed with replaceable parts, ensuring that if one part breaks, it can be replaced without discarding the entire chair. Use of recycled and renewable materials. This is about prioritizing materials that are recycled or renewable to reduce the environmental impact. This includes using materials like reclaimed wood, recycled metals, and biodegradable fabrics. These materials reduce the need for virgin resources and minimize waste. The production processes for these materials often have a lower environmental footprint. The example is Varkoi Kft. And Mate Horvat, who together created a modular sofa family called Match that uses upholstery made of recycled PET bottles and foam made of waste materials created during the production. Design for disassembly. This is about creating products that can be easily taken apart at the end of their life cycle to facilitate recycling and reuse. This involves designing furniture with standardized, easy-to-remove fasteners and avoiding permanent adhesives. This makes it easier to separate different materials for recycling and reuse. One example is Steelcase, who designs furniture that can be disassembled with common tools, making it easier to recycle components at the end of their life. Their Think chair is designed for easy disassembly, allowing for 95% of its materials to be recycled. Closed-loop systems. Implementing systems where materials are continuously reused within the production cycle. These systems aim to keep materials in use for as long as possible, extracting maximum value before recovering and regenerating products and materials at the end of their service life. This reduces the need for new raw materials and minimizes waste. The example is Vitso, who operates a closed-loop system where they take back old products, refurbish them, and then resell them. This reduces waste and the need for new materials. Shift from ownership to access. This is about encouraging models where consumers lease or rent furniture instead of buying it. This model ensures that furniture is returned to the manufacturer at the end of its use period, where it can be refurbished and reused. This reduces waste and promotes the reuse of materials. One example is Ripe Office, who offer office furniture as a service, allowing businesses to lease furniture. This ensures that products are returned, refurbished, and reused. Safe and circular materials. This is about choosing materials that are safe both for the environment and human health and that can be easily recycled or composted. This involves using non-toxic, biodegradable, and recyclable materials. It also includes ensuring that the production processes do not release harmful substances into the environment. One example is Emeco, who uses recycled aluminum and PET in their chairs, ensuring that the materials are safe and can be recycled at the end of their life. Their 111 Navy chair is made of 111 recycled PET bottles. Material use. Let's talk about environmental impact analysis. In the context of circular design, understanding the environmental impact of materials is crucial. This involves evaluating the entire life cycle of materials, from extraction and processing to use and then finally disposal. Key factors to consider include resource extraction, processing and manufacturing, the use phase, and end of life. Resource extraction, the first part, is the initial stage in the life cycle of materials, where raw materials are obtained from the environment. This process has significant environmental and social impacts, which must be carefully managed to align with circular economy principles. Here's a detailed exploration of the key aspects of resource extraction. The types of resources. There are renewable resources. These include materials that can be replenished naturally over short periods, such as timber from sustainably managed forests and bamboo. There's non-renewable resources. These are finite resources that cannot be replenished on a human timescale, such as metals and fossil fuels. Now let's talk about the environmental impacts. These include different impacts for different aspects of production. There's deforestation, which is the removal of trees for timber and other forest products that can lead to habitat loss, reduced biodiversity, and increased carbon emissions. Sustainable forestry practices such as selective logging and reforestation are essential to mitigate these impacts. Soil degradation. Mining and logging can lead to soil erosion, loss of fertility, and contamination. Techniques like contour plowing and phytoremediation can help restore soil health. There's water pollution. Resource extraction often involves the use of chemicals that can contaminate water sources. Implementing strict waste management practices and using less harmful alternatives can reduce water pollution. Air pollution. The extraction and processing of raw materials can release pollutants into the air, contributing to climate change and health problems. Adopting cleaner technologies and reducing emissions are critical steps. Now let's talk about the social impacts, such as community displacement. Large-scale resource extraction projects can displace local communities, leading to loss of homes and livelihoods. Engaging with communities and ensuring fair compensation and relocation plans are vital. Labor conditions. The extraction industry often involves hazardous working conditions. Ensuring safe working environments and fair wages is crucial for social sustainability. Now let's see some sustainable practices in resource extraction. Sustainable forestry is very important. There are certification programs like the Forest Stewardship Council, or FSC, They certify forests that are managed sustainably, ensuring that timber is harvested in a way that maintains the forest biodiversity, productivity, and ecological processes. Agroforestry is about integrating trees into agricultural landscapes that can provide timber and other forest products while enhancing biodiversity and soil health. We have to talk about responsible mining. Recycling metals is a good option because these recycled metals reduce the need for new mining, conserving natural resources and reducing environmental impacts. There are also eco-friendly mining techniques. Methods such as in situ leaching and biomining minimize environmental disruption and reduce the use of harmful chemicals. There are also alternative materials to consider, such as bamboo, which is a rapidly renewable resource, and it can be harvested sustainably and used as an alternative to traditional hardwoods. Reclaimed materials are also an option. Using materials salvaged from old buildings and other structures reduces the demand for new resources and minimizes waste. Processing and manufacturing. They are critical stages in the life cycle of furniture, where raw materials are transformed into finished products. For circular furniture designers, these stages offer numerous opportunities to enhance sustainability and reduce environmental impacts. Here's a detailed exploration of key considerations and practices. Energy efficiency. Renewable energy should be used because utilizing renewable energy sources such as solar or wind power in manufacturing processes can significantly reduce carbon footprints. Investing in modern, energy-efficient machinery and equipment helps lower energy consumption and operational costs. Now let's talk about material efficiency. Using advanced software and machinery to optimize cutting patterns minimizes material waste. Implementing lean manufacturing principles to streamline processes, reduce waste, and improve efficiency. Establishing systems for recycling and reusing offcuts, sawdust, and other byproducts within the manufacturing process also helps. Waste to energy. Converting waste materials into energy through processes like gasification or anaerobic digestion. Then there's water conservation. We have closed-loop water systems. Implementing closed-loop water systems to recycle and reuse water within the manufacturing processes is an efficient way. There are also water-efficient technologies, and using these technologies and practices can reduce water consumption. Chemical management. These include non-toxic finishes. By selecting non-toxic water-based finishes and adhesives to reduce harmful emissions and improve indoor air quality is a good way to go. Safe handling and disposal. Ensuring safe handling, storage, and disposal of chemicals to prevent environmental contamination. Now let's see some sustainable practices in processing and manufacturing. Using eco-friendly materials. By, for example, using sustainable sources. You can source materials from certified sustainable sources such as FSC certified wood that ensures responsible forest management. Incorporating recycled materials such as reclaimed wood or recycled metal into furniture design also helps. There are advanced manufacturing technologies such as CNC machining, using computer numerical control or CNC machining for precise and efficient material cutting and reducing waste, or employing 3D printing technology to create complex designs with minimal material waste. You can also use modular designs with interchangeable parts, designing furniture with interchangeable parts that can be easily replaced or upgraded, extending product lifespan. Ease of assembly and disassembly is also a good way, which is creating designs that are easy to assemble and disassemble, facilitating repair, refurbishment, and recycling. There is collaborative manufacturing, and this includes shared resources, which means collaborating with other companies to share resources such as machinery and materials to reduce cost and environmental impact. We also should talk about local production, which is prioritizing local production to reduce transportation emissions and support local economies. Now let's talk about the use phase. The use phase of a product's life cycle is critical in determining its overall environmental impact. For circular furniture designers, this phase offers opportunities to enhance sustainability by focusing on durability, maintenance, and user engagement. Here's a detailed exploration of key considerations and practices. Let's talk about durability and longevity. These include robust construction, that is, designing furniture with high quality materials and sturdy construction techniques to ensure long-lasting use. This can also mean timeless design, creating designs that remain aesthetically pleasing and functional over time, reducing the need to replace furniture frequently. There is maintenance and repair. Ease of maintenance. This means designing furniture that is easy to clean and maintain, extending its usable life. And also repairability, which is ensuring that furniture can be easily repaired by providing access to spare parts and repair guides. User engagement is very important, which includes education, that is, educating users on how to care for and maintain their furniture to maximize its lifespan, and also customization, that is, offering customizable options that allow users to adapt furniture to their changing needs, reducing the likelihood of disposal. Energy efficiency is also very important. For example, low energy use. For furniture with integrated electronics or lighting, we need to ensure that these components are energy efficient. There are also sometimes smart features, and this means that incorporating smart features will optimize energy use, such as sensors that adjust lighting based on occupancy. Now let's see some sustainable practices in the use phase. For modular design, there could be interchangeable parts. That is, designing furniture with parts that can be easily replaced or upgraded, allowing users to keep their furniture longer. Or adaptability, that is, creating modular designs that can be reconfigured for different uses, extending the product's functional life. There are maintenance programs that offer service plans and repair services to help users keep their furniture in good condition. They can also offer DIY repair kits, which is do-it-yourself repair kits and guides to empower users to fix minor issues themselves. Then there is user education, which can include detailed care instructions with each product to help users maintain their furniture properly, or they can have workshops and tutorials. These can be either online or offline on furniture care and repair. Then there are product take-back programs that include recycling and refurbishment, that is, implementing take-back programs where users can return old furniture for recycling or refurbishment, or offering incentives such as discounts on new purchases to encourage participation in take-back programs. Let's talk about the end-of-life phase. The end-of-life phase is a crucial stage in the life cycle of furniture where products reach the end of their usable life and decisions are made about their disposal or repurposing. For circular furniture designers, this phase offers significant opportunities to minimize environmental impact and promote sustainability. Here's a detailed exploration of key considerations and practices. Recyclability. Choosing materials that can be easily recycled without significant loss of quality. Avoiding composites that are difficult to separate. Creating products that can be easily taken apart, allowing for efficient recycling of individual components. Then there's biodegradability, which means using materials that can naturally decompose without harming the environment, such as untreated wood and natural fibers. Or you can use biodegradable composites. So this involves composites that break down safely in the environment, reducing landfill waste. There's reuse and repurposing. Designing products that can be repurposed or given a second life either in their original form or through creative reuse. Or upcycling, which transforms old furniture into new products with added value, extending the life cycle of materials. Then there is the waste management. The goal here is to create less waste, or if you create waste, to manage that better. Implementing strategies to divert waste from landfills, such as recycling, composting, and energy recovery, or properly managing and disposing of hazardous materials to prevent environmental contamination. Now let's see some sustainable practices in the end-of-life phase. Product take-back programs establishing systems for collecting old furniture from customers, facilitating recycling and refurbishment, or incentives again by offering discounts on new purchases to encourage customers to return old furniture. There could be recycling initiatives, for example, for material recovery, that is, setting up processes for recovering valuable materials from old furniture such as metals, plastics, and wood. There can be different companies can be collaborating with recycling companies to ensure efficient and effective recycling of materials. Refurbishment and resale. There are refurbishment centers where the old furniture can be repaired, refurbished, and resold, giving products a second life. And then we have to talk about quality assurance, that is, ensuring that refurbished products meet high quality standards, providing customers with reliable, sustainable, and safe options. Then there's composting and biodegradation. Using materials that can be composted at the end of their life, returning nutrients to the soil. Designing products that break down naturally, reducing the burden on waste management systems is also a good option. Now let's talk about tools for conducting the environmental impact analysis. The Life Cycle Assessment, or LCA, is a systematic method used to evaluate the environmental impact of a product, process, or service throughout its entire life cycle. This comprehensive approach helps identify areas for improvement and supports decision-making aimed at reducing environmental footprints. The objective is to clearly define the purpose of the LCA study and its intended application. The scope includes determination of the boundaries of the study, including the product system, functional unit, for example, one piece of furniture, and the level of detail required. The steps: goal and scope definition, inventory analysis, impact assessment, and interpretation. Let's talk about inventory analysis. This includes data collection, that is, gather data on all inputs, for example, raw materials, energy, and all outputs, for example, emissions and waste associated with each stage of the life cycle. Then there's modeling. Create a model of the product system that quantifies the flows of material and energy. Then we move on to impact assessment. Here we assign inventory data to relevant environmental impact categories, for example, global warming potential or acidification. Then we move on to characterizations, where we quantify the potential impacts within each category using specific indicators, for example, CO2 equivalents for global warming. Then we do the interpretation. We evaluate the results to identify significant environmental impacts and areas for improvement. After this, we draw our conclusions based on the findings and provide recommendations for reducing environmental impacts. Now, other tools that we can use and methods we can use include Environmental Product Declarations, or EPD. These are standardized documents that provide transparent and comparable information about the environmental impact of products. These include data on resource use, emissions, and waste generation. Then there's carbon footprint analysis, which measures the total greenhouse gas emissions caused directly and indirectly by a product. This involves assessing emissions from raw material extraction, manufacturing, transportation, use, and disposal. And another one we can use is material flow analysis, or MFA, which tracks the flow of materials through a system to identify opportunities for reducing waste and improving efficiency. This is useful for understanding the material inputs and outputs in a manufacturing process. By understanding the environmental impacts of different materials and employing tools for thorough analysis, designers can make informed choices that align with circular economy principles. In summary, circular design is a transformative approach that aims to create products and systems that are regenerative by design. Unlike the traditional linear model of take, make, dispose, circular design focuses on closing the loop, ensuring that materials and products are reused, remanufactured, and recycled, thus minimizing waste and environmental impact.